making the world simple, you could force the conversation down into just electrons, right? You kind of understand electrons. You plug something in the wall, there's an abundance of electrons in one of those little plugs things. That abundance of electrons flows through the wire, turns the light bulb on, and then flows back out through the other side. So one side of the wire has a high potential. One side of the plug, pardon my misphrase, the other side of the plug has no potential, or maybe a negative potential, depending on how you look at it. There might be a third prong on that plug called earth ground, which is a little bit different, something else. We have some engineered solutions we made by studying using science called ground fault interrupt breakers. Those look at the difference between the flow of electrons in one wire and another wire and say something's wrong, and they trip. So you could make the world about electrons. You could make it that simple. You could worship these things. And you could throw in something called frequency, right? Frequency is a repetition. Frequency is something we look for. Frequency is a pattern that we can find. Sometimes to find that frequency pattern that is generated by making electrons shake different ways, that frequency pattern matters. We sometimes have to filter out the noise and find that frequency buried inside of discrete things. That's the secret thing that the space telescope that we were, Arecibo, that fell down, that had huge, massive systems created to eliminate what we think is noise to find a true signal. Electrons. This is kind of electrons. You can make it all about electrons, and that's not the answer. Because those electrons are attached to, related to the element that they're spinning around. Unless they're free electrons out in the, not attached to something, right? These electrons are amazing things to study. You can spend a lifetime in career. You can spend your lifetime in low-frequency electronics and never have to get into the equations of high-frequency electronics. It might be kind of beyond your realm of reasoning why you need to know about high frequencies. There's so much in DC power, DC current, that AC, low frequency AC, like 60 hertz that comes out of your wall. It doesn't hurt. It's a frequency of electrons available from the wall socket. Why don't those electrons leak out into the other electrons that are running electron things around here? Well, simply that's not the way it works, and we have learned about these things. There's some odd peculiarities to the electrons. Once you start looking at them closely, the whole worldview changes. You go into atomic, subatomic particle theories. We're talking about atomic particles now. The elements, table of elements, the table of isotopes that extends those elements and what they do. But each one of those has electrons orbiting around it in circles, in very sophisticated, repetitive cycles around the nucleus of the atom. Do they ever go into the nucleus? We don't think so. We think they're just orbitals around, but they're not circular orbitals like some people show in pictures. The circles are a useful presentation of electrons, but it's not a true presentation of electrons. But the circle is a very good approximation of where the energies for all these electrons lie. And the electrons land in shells. They don't hang out with each other. They've got their own little parts of suburbia out there around the nucleus that they occupy. The nucleus rules dictate how it will bond, how those electrons with hydrogen might bond with an oxygen. And it takes two hydrogens to bond with one oxygen to make water. But if you don't have two hydrogens, what do you make? There's a word for it. So, it's complicated. There is not one answer. We cannot break this down to an absolute. The closer you get to an absolute, the further away it gets. It's a problem with getting halfway somewhere. How many times can you get halfway before you're there? Pieces out. Lots of pieces. It's amazing.